I'm just going to test your observation skills. No, nothing big. This is a rod. The acceleration of rod is A. The acceleration of rod is A. Find the acceleration of the wedge. Acceleration of rod B is A. Find the acceleration of the wedge. Okay, there's an inclined plane. Huh? There's some fixed plane.
Sir, what is the angle made by the fixed plane, sir?
What is the angle made by?
Fixed plane.
Theta, theta. This is theta.
Okay, sir.
This I'll not give. It's not needed. It's a wedge, no? Something. It's a wedge. That one. There's the best question. Let's see that how you. Okay. Meanwhile, go for free body diagram. I'll finish off coloring part. Go for free body diagram. Take help of the free body diagram. Then, of course, he has not given masses, no. So it is all about the constraint equation is what you have to think. Are you getting no? So try to make observation. Like the way he asks questions, no, you have to be really careful. So don't assume yourself some masses. Some students, I don't know, like they just want to follow the routine method. Mass of the wedge. He didn't ask anything about. He didn't give mass of the rod, mass of the wedge. Only has given acceleration of the rod. Is asking the acceleration of the wedge. Okay, there's a diagram. You have to fight with the diagram. Acceleration of the rod B. There's a rod B. Okay, how the wedge will move? Anybody? How the wedge will move?
Towards left, sir.
Towards left. Okay, good. The wedge will move towards left. So we are very sure that the wedge will move towards left. Then it's saying acceleration of the rod B is A. How the acceleration of rod is? Acceleration of the rod. Sir, he has given acceleration of the rod is A, but he didn't say anything about the direction, no? Look at this. Acceleration of the rod B is A. Or if you want to write A naught in anything, any other symbol, acceleration of the rod B is A. So it's not telling like direction. Will it be vertically up? Rod B will move vertically up. No, no way. No, not vertically up. Then vertically down.
Mm.
Vertically down.
Yes, sir. Down.
No, sir.
It will move in a plane, sir.
So vertically down and towards left.
Along the plane, no,
Sir, along the fixed plane, sir.
along the fixed
Along
plane,
the-
along the plane. See, this is no way, no formula, nothing will help you. So what will help you here? Your common sense, no, the observation. I'm suggesting you the physics. This is the only parameter which will make the difference between students. Who will make observation? So everyone, what will try to move with the formula? No, the small ideas like see. The rod will be as the rod slides, it will in contact with the fixed plane. So I'll start the reason. Third quadrant, yeah, fine. The rod will be chandelier, okay, fine, yeah. The rod B will move in the third quadrant. Now you see that one rod B as it slides, it will be in contact with the fixed plane. Will it lose contact? What do you mean by that? Will it lose contact here? Will it lose contact? The rod and this, will it lose contact?
No.
Rod be an inclined. No,
No,
it will
sir.
not lose
No,
contact.
sir.
So therefore, acceleration of the rod perpendicular to fixed plane must be 0. So therefore, how the acceleration of the rod? The acceleration of the rod must be along the fixed plane, not vertically down. Okay, now you're getting to the problem. Once you get this, rest all you can manage. So how the acceleration of the rod will be? It will be directed in this way. And I'm showing near to the fixed plane so that it will be easy for you. It should be parallel to inclined plane. If you can agree this, then only you can get into the problem. Rod is not moving vertically down. Rod.
Yes, sir.
Okay, now is asking acceleration of wedge. Okay, try to equate. Then is it rod in contact with the wedge as the acceleration along common normal must be equal, no? For this inclined plane. Let's focus more on that inclined plane. So I'll bring that inclined plane. There's a, okay, blue color, yeah. There's a thing. What are the other angles? So they should be thing that one here. Let me take some reference line. Okay, let's come for all the angles. Huh? So what can be this? This angle is theta. We are very sure this angle is theta, so therefore this should be theta. Then what should be this angle? Anybody? Should also be theta, no? And this should be theta. Because I'll extend this line. Huh? This should be theta. What is alpha here? So some this angle we don't know. We'll call that as some let it be that one. I think so. Here I'll help you with some other thing. So what I did is I just extended these lines. I just worked out everything here. So here this should be the theta. If this is theta, Tell me, like, this should be theta. This should be theta. Agreed, all of you? The way I'm bringing the angles. Okay.
Yes, sir.
Okay, so I'll draw it. I'll draw it. No, not needed. Not needed. Not needed. I'll extend the line. Huh? It should be parallel to this. So this should be the one more line is needed, no? Now get into the thing now. So this should be the theta. From the geometry, this is theta. So then this should be theta. This should be theta. What about this angle? If this is theta, I think this angle is needed. Huh? I think this I'll give theta. That one here. This angle of the wedge is needed. Huh? So therefore, this should be. I'll bring in the question itself. I'll make that theta. So this will be theta. This will be theta. This only I just the same this triangle only I just shown it here. Okay, let's come for that one. Now I have to bring one angle. So the normal, which is the rod and the wedge, they're in contact, no? So therefore, what happened? The acceleration of the wedge and the rod along common normal must be equal. So way to bring common normal now. That's all about the problem. So the common normal, I'll show it here. So this should be the some other color. Okay, are you getting this one? So this is the common normal. Okay, let's indicate all the angles here. So this was a theta, this total angle. So let me call this is say some alpha. Look at all of you. Arrows plays very important. So what is this? What is this line I should call? Anybody? Normal to inclined plane of wedge. Call this is say some n cap, whatever that one. So now let's come for that one. How the acceleration of wedge will be towards left. The acceleration of the wedge should be towards left. Acceleration of the rod, how it will be along the incline. Acceleration of the rod, red color we use, no? So acceleration of the rod is like this. Acceleration of the wedge will be in this direction. What should be equal now here? Any relation between the angles? So and this angle should be 90 degree. The total angle. This total angle should be 90 degrees. Now why 90 degrees? Because it is perpendicular to the inclined plane. So this is that inclined plane of wedge. So what is the first foremost condition you can write it? Acceleration First 2 theta minus alpha should be 90 degrees. 2 theta minus alpha should be 90 degree. Please do make observation. Your geometry should be strong enough. 2 theta minus alpha should be 90 degrees. So what is alpha? Alpha should be equal to 2 theta minus 90. Keep it like this here. Let's come for this one. Acceleration along common normal. Normal to inclined plane must be equal because the rod will not lose contact with the wedge. So what is the equations? We'll write it here. I'll write down the equations now. Acceleration of rod must be equal to acceleration of wedge along, so I'll call this is n cap, some unit vector. Acceleration of rod along n cap must be equal to acceleration of wedge along n cap. No, acceleration of the rod along n cap. Acceleration of the rod is A, no? So along n cap should be how much? A cos alpha. No, acceleration of the wedge is how much? A, that one. So along this direction, how much it should be? Anybody? What shall I write?
A cos theta minus alpha.
No, A cos alpha is this one, no?
A cos theta minus alpha.
Theta is this one, no? The theta is this one. So along the perpendicular, it should be A sine theta only. Because you bring that acceleration of the wedge somewhere here. And this will become normal, no? N cap. 90 degree it is making. Getting the idea, no? This should be. So we don't know alpha. That alpha, I'll replace it here, no? Cos of 2 theta minus 90 degree. I think we are at the very near to the problem. No. What is cos 2 theta minus 90? Should be sine 2 theta. Two sine theta cos theta. So acceleration of the wedge will be 2a cos theta. This is the concept. This is the concept, this idea. No, you should not. This is the main idea of the total problem. Without this, I think no way you can manage the problem.
Excuse me, sir.
Why they should be, why you can say, so why you are equating this one? The reason for that is the wedge is in contact with the rod, no? So acceleration of the wedge and the rod along normal to inclined plane must be equal. Yes, Aman, yeah.
Sir, can you explain why acceleration of wedge along n cap is A sine theta, sir?
This is, I think, perpendicular. So I'll do one thing. If this is theta, this is the 90 degrees. What you write? What you write? Acceleration of A along n cap. A sine theta, no? Along the inclined plane should be A cos theta. Okay?
Yes, sir.
Because 90 degree, I'm showing that yellow color one, that you have to make it out.
Okay, sir. Thank you, sir.
Now I'll give, almost everyone is having trouble with that. And I'll draw one more diagram. This is the n cap, no? Okay, got no. That's, I'm making things very easy for you. No, this should be the 90 degrees. Huh? Okay, we'll move for next. Huh? I think it took a lot of time, this question.
Sir, once screwed up, sir, I'll take a screenshot. Done, sir.
Completed. Yeah.